Hi there, how you doing? It's me again, Steve Bedder from Autodesk in the UK. So we're going to have a look at some of the design accelerators that we've got inside of Autodesk Inventor. We're using Autodesk Inventor 2011 here, and what we want to do is we want to design a drive system between the motor here and also a drive table that we're going to place on top of this casting. Now, to do this, we're going to use one of the 25 different design accelerators that we've got inside of Autodesk Inventor, and we're going to have a look at as many of those as we can over the next 5 or 6 minutes. But first thing that I want to do is design the shaft that's going to transfer the drive from the motor onto the actual table itself. Now, we can use the shaft component generator, and we can generate lots of different sections. We can include sections and splines and internal bores, etc. But we can also reuse existing geometry. So in this case, we've just taken a 2D sketch that was originally created inside of AutoCAD, and we've used that as the basis for the external profile of our shaft. Now, to reduce the weight of this shaft, we're going to put some internal bores on this, and we can see that we can include these bores and that we can dynamically drag the size of these internal bores directly on screen. So I'm just using my mouse here and just changing the dimension, but if I want a little bit more control, I can add in the diameter and I can also add in the length into a dialog box as I'm doing here, and that'll create the internal bore on the left. And now I want to create the internal bore from the right. So again, I can drag this up, but you notice it doesn't quite snap in place. We want it to align up with the end of the section on the left. So to do this, I can just use the little padlock in that dialog box, and it will automatically align itself with the end section on the left. So that'll mean that any changes that we make, we only need to make the one change to the one side of the section. We don't need to do that twice. Now let's just use our part feature priority here, and just to remove some of the components so we can see what's going on here. So I'm just going to turn the visibility off of some of these components, and we can see there that without having to even sketch anything or extrude or revolve, Inventor has created for us that shaft. So now I want to transfer the drive from the motor to the shaft. So we're going to use our synchronous belt tool. We can create chains, we can create pulleys, we can also create synchronous belts, and all this is done based on international standards, so ISO standards, ANSI standards, DIN standards that we can choose from that drop list. And you can see I'm actually reusing a pulley or a synchronous belt that I've used before, so it's remembered the last known configuration, and this will allow me to just specify the position of those pulleys. Now, I don't know if you noticed there, but that line that traces around those three pulleys was red a moment ago, but now it's gone green. And the reason it's gone from red to green is because we've moved the position of the pulleys from a non-standard belt size to a standard belt size based on the standard that we're actually working with. So this is ensuring that we're getting things right first time, and that that we're not using non-standard components that we can't order. I've just used the new assemble tool there for 2011 to position the idler. Not needed to use any of the constraint tools, we just use that new assemble tool to place it into position. And now to transfer the drive from that pulley onto the shaft, we need to place in there a parallel spline. So again, we're using standard based design. I'm using an ISO standard here, and the ISO told me that the light series that I'd chosen, there wasn't a size large enough for that, so I immediately was able to then go and choose the medium series, where again I can specify the functional sizes for this spline. I can choose from a list of standard sizes, so I'm not making errors here by choosing the wrong size or inputting the wrong size, and I can just let Inventor do the work for me and go and design or place in there the interface between the shaft and the actual pulley. So again, I've not had to create any type of sketch, I've not had to create any type of extrusion. I'm just functionally designing the requirements for this drive system and letting Inventor do the work for us. It's almost like having a design engineer's handbook or a machinery's handbook built directly into Autodesk Inventor. Now, one of the final things to do here is let's apply the keyway between the actual motor itself and the pulley. And again, we're using an ISO standard here. We can choose the position, and I can dynamically select on screen. I can dynamically drag the size, and again this snaps to the relevant sizes for the ISO standard that we're working with. So again, it makes sure that we're creating a key that we can actually buy off the shelf. We've got a list of all the different types of standard keys that we can choose from. I can also choose to put multiple keys in. So again, if I want to increase strength and reliability here, I can specify that I actually want 2 keys, specify the angle, and again let Inventor do all this work for us. But not only are we actually asking Inventor to do the design work, we can also check that this key is fit for purpose. So with all of the design accelerators, as well as the design side, there's also the calculation side, so that you can check that what you're designing is actually going to be fit for purpose and is going to work for the job that you want it to do. So we've designed the drive system there, or we've let Inventor design the drive system. We've just made the functional decisions that we as a design engineer need to. So the next thing that I want to do is actually bolt the dial table onto that shaft. So again, we're going to use the bolted connection component generator. Just choose the position of the bolts, so in this case the top face of the table, the existing bolt pattern hole, and I'm just going to ask it to terminate on the underside of that shaft section. And I can choose from our extensive content center library, where we've got over 1.1 million standard parts. I can go and choose the type of bolt that I actually want, and I can configure the bolts and the washers and the nuts, etc. Again, all based on international standards, so you don't need to go and find any of those sizes out from your Zeus tables or from your machinery's handbook. We can get them all directly from within Inventor. Or we can also include templates. So if you use a particular fastener template on a regular basis, just save that template away and reuse it. Just like with the other design accelerators that we saw, we've also got a calculation tool for the bolted connection. So again, we can check for strength, and we can check for the number of bolts that are required. Just input the forces that are going to be impacting upon that bolt, and then let the design accelerator do the work for us, check that it's going to be fit for purpose, and then also include all of those nuts, bolts and washers into the design without me having to do any type of sketches, extrusions, revolves, lofts, etc. We're using the functional design tools inside of Inventor to help us get it right first time.